Right, this video is about inverses, and so in this video we're going to determine if the given functions f and g are inverses by taking compositions. So in the first example, f of x is 3 over x minus 2, and the second, and g of x is 3 over x minus 2. So the composition f of g of x looks like this. This would be f of, and you replace g of x with what it's defined to be, 3 over x plus 2. And then in the f function you replace x, everywhere you see x, with what we have right here. So this is equal to, f of x is 3 over x minus 2. So this would be 3 over something minus 2. And the something that we put in here is whatever we find in this parentheses, 3 over x plus 2. So now we have to work with this, and what I see here is a complex fraction. So let's try to simplify that. We have 3 over 1 over 3 over x plus 2 minus 2. And so let's simplify this complex fraction, and we are allowed to keep, change, flip, or take the numerator and divide it by the denominator. So to simplify this part, it looks like 3 over 1 times x plus 2 over 3. And this is minus 2. These 3's will divide into each other to become a 1. We are left with 1 times x plus 2, which is x plus 2 over 1 minus 2. So this is simply x plus 2 minus 2, and it simplifies down to x. That was just taking f of g of x. Now let's take g of f of x and see what happens. Alright, when we take g of f of x, we have, this will be g of f of x is defined to be 3 over x minus 2. So in the g function, which is right here, we replace every x with what we find in the parentheses right here. So this expression, let me draw a line right here. This expression will be 3 over x plus 2. And the x is 3 over x plus 2. Alright. So let me rewrite this clearer. This is 3 over x plus 2. Am I missing something? 3 over x plus 2 minus, oh, this should be a minus 2. Minus 2 plus 2. That's what I'm missing. This should be a minus 2. 3 over x minus 2 plus 2. 3 over x minus 2 plus 2. Okay, so this is a complex fraction. We have to simplify it. This time, this is not sort of a nice and tight one where you can do the keep, change, flip, keep the numerator, multiply by the reciprocal of the denominator, because this is a subtraction going on here. So I'm going to choose to simplify this complex fraction simply by multiplying the numerator and the denominator by the lowest common denominator that I see. So when I look at this, I see the numerator is a 3. It does not have a denominator. In the denominator, I see this 3 over x. So that is the denominator I'm looking at. The lowest common denominator will be simply x. So I'm going to choose to multiply the numerator by x and the denominator by x. And it will go like this. Well, you know what? I'm going to do that, but I just see this marker so dang big. That's why this is looking so sloppy. Let me rewrite. I'm just going to rewrite this phrase one more time so it's not so complicated. We have a 3 over x minus 2 plus 2. And this is in parentheses. Alright, this is our denominator. But if I look at this denominator, what is in front of this is a 1, and I don't really need these parentheses because that's a 1. I could distribute the 1 and it would look the same. So what that means is I'm allowed to think of this as 3 over x minus 2 plus 2. And then these are free to be combined. Negative 2 plus 2 is 0. Now I have 3 over x. And so now I see this is a nice tight fraction. This is 3 over 1 over 3 over x. So I can say this is 3 over 1 times the reciprocal, x over 3. 3 will go into 3 one time, and I'm left with 1 times x over 1 times 1, which gives me x. I got, when I took f of g of x and simplified it down, I got x. When I took g of f of x, I got x. And when I took f of g of x up here and simplified it down, I also just got x. So it said determine if f and g are inverses by taking the compositions f of g of x and g of f of x. Well, I've just determined that they are, in fact, inverses, because when I took f of g of x, I got x, meaning they undo each other both ways. So my conclusion would be yes, f and g are inverse functions. Okay, now let's do this other one. I ran out of room, so here's some more paper. Let's look at number 2. And so number 2 goes like this. Here are my 2 functions for this one. I want, for number 2, I'm going to take, what is f of g of x? Okay, f of g of x is equal to f of whatever I have for g of x. X minus 7 to the 3rd power plus 1. And so that is going to be equal to the f function, the cube root of x, whatever, and this is what I have for x, this whole expression, x minus 7 to the 3rd power plus 1, that's what I put in there for x, plus 7 minus 1. So now I see that this is the cube root of x minus 7 to the 3rd power plus 8 minus 1. And there is not, this is not going to simplify further. It's not going to start to cancel out anything, and this is what I get, and I can't simplify this down to just being x. So at this point I can say, oh, since if f of g of x does not equal to x, I don't even have to do it the other way, g of f of x. This is enough for me to say, no, f and g are not inverse functions. That is my conclusion.